Any doubts from the last lecture? The last lecture we finished this thing, Kirchhoff law. Nabil, Hishma, Kinza, Binashi, Yashika. Any doubts? Am I audible?
Yes, sir.
So in the last lecture, we have finished this thing, like we have finished Kirchhoff law, and we also derived the balancing condition of Wheatstone bridge using Kirchhoff law. The next, we have few instruments. There were two instruments in the syllabus. One is meter bridge, another is potentiometer. Potentiometer is deleted for the session 2022-2023. So we will not do that potentiometer in our usual class. But we will do potentiometer when we revise this current electricity for JEE and NEET exams. So see, what is meter bridge? See, I will use some slides. This is meter bridge. Meter bridge is practical application of Wheatstone bridge. When you use Wheatstone bridge practically, the thing that you get is meter bridge. This is meter bridge. It's a practical application of Wheatstone. So what is Wheatstone bridge? Nothing but the practical application of Wheatstone bridge. Wheatstone bridge is a theoretical model. When you use Wheatstone bridge in an experiment or practically, then what we get is meter bridge. We use meter bridge to calculate unknown resistance. So to calculate unknown resistance, like if I give you a wire, I ask you to calculate the resistance of the wire. To calculate resistance of the wire, we use meter bridge. It's used to calculate unknown resistance. So the next thing is principle. This meter bridge is based on the principle of Wheatstone bridge. What was the principle of Wheatstone bridge? Kinza will tell. Kinza, what was Wheatstone bridge? What was the balancing condition for Wheatstone bridge, Kinza?
R1 by R2 is equals to R3 by R4.
R1 by R2 is R3 by R4. That means the bridge is balanced. If bridge is balanced, that means no current will pass through the galvanometer. It's the same principle on which this meter bridge is based. If R1 by R2 is R3 by R4, this is your Wheatstone bridge. No current will pass through this galvanometer. Current through the galvanometer will be zero. So this is principle of this thing. We'll draw it. These are slides from my last year lecture. It saves some time. It means I don't have to write all the variables. Now see how to draw this meter bridge. So to draw this meter bridge, we keep Wheatstone bridge. We draw meter bridge using Wheatstone bridge. So let's start from this point. In between points A and B, you have a resistance R. So when we draw meter bridge from Wheatstone bridge, what we do is we replace straight wires by thick copper strips. So instead of these straight wires, we will be using copper strips. Instead of straight wire, we use very thick copper strips. Instead of straight wire, we use these thick copper strips. These are copper strips. These are the copper strips in the real diagram. These are the copper strips. These are the copper strips. When you do this practical in your laboratory labs too, these are the copper strips, thick copper strips. I call this point as A. This is point A. This A is here, and this point C is here. This is point C. If this is A, then this point is also A. Can anyone tell why, if this is A, this should be also A? Or the reason of taking this and this both as A? Answers. See, this is copper. Copper is a conductor. All points of conductor are at same potential. So this A and A are at same potential. Is my mic working properly? Can you hear me properly? Anshika, Arpit, Hishma, Minashi, am I audible?
Yes, sir.
Yes, sir.
Okay, I thought my mic is not working. So I'm asking why potential over this point and this point is same? What's the reason? Just general question. Anyone can answer. Why point A and this point and this point can have same potential? Yoshika, why this and this will have?
Branch between the 2 points.
Oh, no. Because it's a conductor, all points on a conductor are at same potential. This and this on the conductor, na? Points on the conductor are at same potential. If this is C, then this is also C. These are identical points. If you take a wire, you say, okay, the potential over this end is 10 volt. Then potential here is also 10 volt. Potential here is also 10 volt. All points are at same potential. Let's call this point as B. If this is B, then this is also B. Saifullah, which resistor is connected between A and B? Just look at this Wheatstone bridge and tell me. Which resistor is in between A and B? R1 is in between A and B. So in this between this A and B, I connected a resistor.
One question, sir. Sir, you said that in a wire we can consider all points to have same potential, right, sir?
Yeah,
but
because it's, yeah.
Sir, but in our NCERT textbook, for proof of Ohm's law, like for finding out that it is inversely proportional, it is directly proportional to length. We had said that when two wires are joined together, then the potential increases.
Yes.
And resistance increases. That means.
But for that expression, when you write V is equal to IR, you say that voltage increases with length. Then you say that current is also constant. Because if current is variable, then you can't decide your potential, right?
Yes,
You're
sir.
saying that V is proportional to L. Basically, you are saying that V is I, R could be written as OL by A. So you're saying that V is directly proportional to L, right?
Yes,
So
sir.
this is true only if your I is vary. I does not vary. But here I will also vary in such a way that potential will remain.
Yes, sir.
All points potential is same. Or you can go to this result easily through the concept of equipotential surface. In potential, we did some equipotential surfaces. Equipotential surfaces means these are those surfaces at every point of which potential is same. So in between A and B, we connected R. What resistor is connected between B and C, Anshika? Which resistor is connected between B and C? Just look at this diagram and tell me. Which resistor should I connect between B and C? Anshika, you are not in class.
Sir, it is R.
R2. Arpit, which two resistors are left? R3 and R4, na?
Yes, sir.
So for R3 and R4, we take a wire. The length of this wire is 1 meter. Due to this 1 meter length, we call this bridge as meter bridge. So meter bridge simply means bridge having a wire of 1 meter. For the next task is to decide out of this whole wire, how much portion is for R3 and what portion is for R4. To decide R3 and R4, we first have to decide this point D. To decide this point D, we need a galvanometer. So what we do is, see, galvanometer is connected between point B and point B. So this is B, this is B, so this is also point B. I connected a galvanometer through this point. Then I need a point D. This D will lie somewhere on the wire. But the special thing about point D is, if I find point D, then current in the galvanometer should be zero. The galvanometer should not show any deflection. So what I did is, I take a wire from other end of the galvanometer. See, galvanometer have two ends. This is one end, this is another end. One end is connected to this point D. And I take another end. And I keep on sliding this another end from point A to point C. I'm sliding it from A to C. So while sliding from A to C, we came across a point which we call, and at this point, the current in the galvanometer becomes zero. If current in the galvanometer becomes zero, that means your bridge is balanced, which means we have found this point. I'm repeating it again. Let's do it again. We have all points, ABC points we know. We have to find point D. To find point D, we know that current passing through B and D is zero. If we can find point D, then current through the galvanometer should be zero. So what we do is, we take this galvanometer, we connect this galvanometer to one end of the bridge, and to the other end of the bridge, the other end of the galvanometer, we start sliding it from A to C. When we slide it from A to C, then in between A and C, I find a point D. I find a point corresponding to which Ig is 0. And I call this point as point D. This is my point at which current in the galvanometer is 0. The resistance to the left of DC between A and D, this is R3. So that's your R3 resistance. And this resistance is R. Is it clear up to here how we find point D here? Any doubt? Munib, Nabil Khan, Ishma?
No.
Hold on. So now we have our point. Then we connect a cell between A and C. We connected a cell between points A and C. See, the cell is in between A and C. The cell is between A and C. Length is, the length of the whole wire is 1 meter. So you can say that the length of the whole wire is 100 centimeters. So when we do this practical, what are your observations? Have you done this practically in your school?
Yes, sir.
What observation you take when you do this practical in your school?
Length at which the galvanometer reading is 0.
Right, good. What we take is, we take this length L, the length corresponding to which the reading of the galvanometer is. We take this length L, and the remaining will be 100. So this is your observation. So there is a scale here. This is a scale here. So from this scale, let's say this is your galvanometer. This is your point D. So using this scale, you can measure this length. If let's say this length is 60 centimeter, Then the remaining will be 100 minus 60. So that will be 40 centimeter. So that complete length come out to be 1 meter or 100 centimeter. So this is R3, R4, R1 and R2 and this is the given value. This arrow here, this particular arrow here is the jockey. This arrow here is the jockey. This is the jockey. The jockey is just a pen type instrument. This is jockey. Right? This is jockey. We use jockey to make temporary contacts. So instead of connecting this wire directly to this wire, we connect it through the jockey. Jockey is just a pen type material used to make temporary contacts. Is it clear up to this point?
Yes, sir.
Yes, sir.
Okay. Now your aim is, the theory of this calculation is somehow you have to relate this R1, R2 with this L. See, this L is representing this resistance R3. This 100 minus L length is representing this resistance R4. So I can even write this as, what is R3? R3 is the resistance corresponding to length L. Similarly, we can use R4. What is R4? Its resistance corresponding to length 100 minus L. And we define something which is small r. Small r is resistance per unit length, resistance per unit length of meter bridge wire. So small r is the resistance per unit length of this wire is. So how much is R3? Can you write R3 in terms of small r and L? What will be R3? Saifullah. Small r is resistance for unit length. So what will be R3 in terms of L and small r? Rashi, what will be R3? R3 is resistance for length L and small r is resistance per unit length. Okay, Ishma, R3 in terms of L and R. Akshay,
L ohm.
sorry. How much?
L ohm.
No, L into R. See, R is resistance per unit length. For length L, the resistance will be L into R only. Yeah? So that's L
So-
into R.
So we can write L ohm also, right?
Not L ohm, L into R. Oh.
Okay.
Similarly, Kinza, what will be R4?
L into R.
L into R.
100 minus
100 minus L into R.
Sorry.
It's 100 minus L into R. And what is the balancing condition, Arpit? If this Wheatstone bridge is balanced, what does it mean? R1 by R2 is R2. So we can write R1 by R2 is R3 by R4. We can write this R3 here. And this R4. So it will be R1 by R2 is L into small r divided by its 100 minus L into small. So see the small r and small r will get cancelled. So you have R1 by R2 is L by 100. So when you do experiments in school, so out of this R1 and R2, one of the resistor is known. Usually this is the resistance box. You know this resistance, this is unknown. And you can keep any name of this. Instead of R1 and R2, you can use PQR as the decimal choice. So changing the name will not change the theory.
Sir, what is that box structure?
That's a resistance box. You use that in your practical. That's a resistance box. You can like this is a resistance box. Each of these keys have some definite resistance. Let's say this key is of 100 ohm. If you pull this 100 ohm key, then the resistance in the circuit will be 100 ohm. If you pull this key, the resistance in the circuit will be corresponding to this particular. So these are known.
Okay, sir.
Noted down. And tell me if you have any doubts. Raj, is it clear?
That's the one making it work.
Nabil Khan, any doubt on this topic?
No, sir.
Can I scroll it?
No, sir.
Tell me once you have written and scrolled.
So you can scroll down.
Miraj, doubts?
Sir, how will we find out the small r value?
This is we have assumed. See, it gets cancelled out in the subsequent calculation.
Okay,
This
sir.
we have assumed that resistance per unit length of the wire is small.
So for practical calculation, we won't need small r, right?
You
Sir?
won't need it. You won't need it. See, the calculation depends only over R1, R2. Written?
Sir, can you show the diagram for me? The above one, sir.
Above. This can I scroll it?
Yes, sir.
So everyone have written up to here, no? Anshika, Nabil Khan, Akshay.
Yes, sir. Yes, sir.
So that is the theory. When you do experiment, you have this resistance, which is your R. So when you do numerical, you have to keep one thing in mind, that whenever you write R1, R1 is not just a resistance. R1 is resistance in left gap. This is the resistance in left. What is R2? R2 is resistance in right gap. If you exchange R1 and R2 on exchanging or interchanging R1 and R2, means instead of R1 you place R2 and instead of R2 you place R1. On interchanging R1 and R2, what you get is you get R2 by R1, which is 100 minus L divided. So this is the importance of this, of keeping in mind the left and the right. If you exchange the resistor, the left one goes to right and right one goes to left, then this balancing condition will change. It will be R2 by R1 into 100 minus. That's the first conceptual question on meter bridge. The next conceptual question that can be asked is, what will happen if we interchange galvanometer itself? See, on interchanging galvanometer itself, Wheatstone bridge does not change. Like if in this Wheatstone bridge, instead of this galvanometer, I place this cell. And instead of cell, I place galvanometer, then there will be no effect on the Wheatstone bridge. There will be no change in the balancing condition, or everything will remain as it is. So on interchanging, cell and galvanometer. So when you interchange cell and galvanometer, balancing condition will change. Balancing condition. So when you interchange cell and galvanometer, instead of cell you use galvanometer, instead of galvanometer you use cell, the balancing condition will not change. Things will remain same. So these are two conceptual questions. Then one can get on this. Just note it down. Then we will do some breaks. Tell me once you have it.
Done, sir.
Moment, sir.
Who is writing?
Yes, sir.
Let's start with this one. Note down the question. Note down the question first. After writing question, at least note down the given data. What data is given? We'll solve it together, but at least write down the given data. What data is given? Also, in numericals of Beatstone, this meter bridge, diagram is mandatory. You have to draw diagram. There are marks for drawing diagram. You won't get full marks if you don't draw meter bridge in its middle. Everyone have written? Yashika, Uneeb, Anshika, Arpit?
Yes, sir.
Okay. Nabil Khan, written?
Yes, sir.
Okay, Nabil, let's start with you. Nabil, on the left gap, the resistance is R. On the right gap, the resistance is S. And the balancing length is 40 centimeters. Can you connect this RS and this 40? This is your L balancing. Use formula of meter bridge and try to connect this RS and L. Nabil Khan. See, Nabil, this is the formula. Huh? R1 by R2, we did this thing. R1 by R2 is alpha, alpha.
R1 by R2 equals.
Instead of R, this is R. Instead of R2, we have S. Equals, then it was L by 100 minus L. So how much is L?
40.
40. So it's 40 by 100 minus 40. Kinza, is it clear?
Yes, sir.
So what we get is, we get it's 40 divided by 60. So divided by 2, it's 2 by 3. So what we get is, it's R by S is equal to, it's 2 by 3. That's now, if instead of, if I connect a resistor of 12 ohm in parallel with this. So in parallel with this, we connected a resistance of 12. The null point occurs at 50 centimeters. So what is the equivalent resistance, Hishma, if I connect 12 and this S in parallel? What is the RE equivalent of this system? Ishma. Saifullah, if I connect this 12 in parallel with this S, what is the equivalent resistance of 12 and S in parallel?
It will be 12,
Hmm?
12s
Hmm.
by 12 plus s.
Yes, this is how we do parallel combination. R1, R2 by R1 plus R2. Ishma, is it clear now?
Yes, sir.
12 plus 6. So on the right arm, we have this resistance 12 into S by 12 plus 6. Arpit, how will you write now? And the balancing condition, balancing is length is now 50 centimeters. How will you write the formula for meter bridge now? Arpit,
Sir, we will equate them.
what? Equate what? First tell me the formula. Na? In the left gap, you have R. In the right gap, now you have 12 S by 12 plus S. How will you write the formula? R by S is L. R1 by R2 is L by 100. This is the formula. Na?
Yes,
What is L? What is R1?
sir, it is
R.
yes.
What is R2?
Yes.
How much is R2? Arpit. R2. Sorry, you're not audible. R2 is? Arpit. Anshika, how much is R2? Like you all have to
Sir,
open your
12
videos.
ohm.
12 ohm. See, in the right gap, we have parallel combination of 12 and S. We calculated it to be 12S by 12 plus S. So what is R2? R2 is the resistance in the right gap. In the right gap, you just have S or you have 12 parallel combination of 12 and S. Anshika.
So parallel.
So what is the final result of this parallel combination? What is
So
R2 now?
12 is upon 12 plus.
So this 12S upon 12 plus S. Upon 12. What is the balancing condition now, Hishma? If I connect this 12 ohm in parallel, what is the balancing condition now? Balancing length. Hishma, you are not listening. Nabil Khan, what is the balancing condition now? Balancing length when I connect this 12 ohm in parallel. Akshay, balancing length.
50 by
Just read the question. Now, when you connect 12 ohm in parallel with us, yes, the balance occur at 50 centimeter from it. So the balancing length is 50 centimeter. Instead of L, we'll write 50. So it's 50 by 100 minus 50. You can take this 12 as to the numerator. Arpit, is it clear now?
Yes.
Arpit, just switch on your video. You are again wasting your time. Switch on your video. You are not attentive. So this is R into 12 plus S by 12S, which is 50 by 100 minus 50 square. Now you have to solve these two equations and get the value of R and S. Solve these two equations and get the value of R and S. Do it. What happened, Arpit? You're not getting these calculations? Should I repeat it again?
Yes, sir, it's confusing.
Meter bridge is confusing. See, this is the formula that we use in meter bridge. R1 by R2 is L by 100 minus L. Hishma, listen again. R1 is the resistance in the left gap, R2 is the resistance in the right gap, and L is the balancing condition. Okay, Arpit?
Yes, sir.
Initially, resistance in the left gap is R, resistance in the right gap is S, and the balancing length is 40. So instead of R1, we have R. What is R2, Arpit?
Sir, 12s by 12 plus s.
Happy, that is read the question. You're not even reading the question. Just read the question. There are two conditions. Now earlier there is
Sir,
just
the equivalent resistance at that point is that only.
there are two conditions. See, initially the resistance in the left gap is R, resistance in the right gap is S, and the balancing length is 40 centimeters. Okay. Then what we did is, then we connected a 12 ohm resistor in parallel with this. Okay, I'm drawing different. Sir. What I did is, in the left arm we have resistance R, in the right arm we have resistances. We connected at 12 ohm in parallel with this. Okay.
Yes, yes, sir.
And now the balancing length is 50 centimeters. Are you getting the two parts now?
Yes, yes, sir.
So what is the resistance in the right arm now?
Sir, yes.
Initially it was this. And balancing length was?
Sir, 40. Initially it was 40.
Now what is the resistance in the right arm?
Sir, that is equivalent resistance, sir.
And how much is that equivalent resistance?
Sir, sir, what is S?
The parallel combination of 12 and S, na?
Yes, sir.
And how much is that parallel combination?
12 plus S.
12 plus S. This is how we add resistance in parallel. तबीयत सही है तुम्हारी
Yes,
यार? तबीयत
Yes, sir.
सही है?
नहीं, sir, 1 by 12 plus 1.
This is, when you do parallel combination, this is 12S by
Yes.
12 plus S, na?
Yes, sir.
So this is the resistance in the right arm. Balancing length is 50 by 100 times. Is it clear now?
Yes.
Abhi switch on your video.
So it is switched on, sir.
Okay. Anyone else have doubts? Nabil Khan, Akshay. Akshay sent the answer. Okay, Akshay, I'm just checking. What about the rest? Kinza, Unir, Nabil, answers? Please share answers on the chat room. Okay.
Sir,
Yes, yes. Saifullah, just check your calculations once more. Nabil Ahmed, your answers of R and S, just solve equation 1 and 2 and get the value of R and S. Yashika, Yashika, just calculate R now. Minashi, your answers. Kinza. It's a simple calculation. Right? You have two equations and two variables. You can divide them and get the value of one of the variable at least. Okay. Only best is right now calculate this thing. R. Minashi. Okay, Yashika, it's correct. Good. You're doing. Kinza. Yes, Saifullah. Now you are correct. Yes, Unif. R is right. R is correct. Nabil Ahmed, no answer. Minashi, Kinza, Ishma, Arpit.
Sir, I'm doing.
Okay, Saifullah. Good. Nabil Ahmed, Nabil Khan, no answers from your side.
send you in WhatsApp or in chat, sir?
No, on the chat. It's the co-host. I'm the co-host. Nabil Khan, you're not solving.
Sir, are you OP or co-host?
Co-host. So if I divide this equation 1 into
Censor.
Nabil Ahmed, okay, correct answers. Nabil Khan, Minashi, Ishma, Kinza, no answer.
Yes, sir.
Sending? Send your answer. Huh? See, you have to solve 1 and 2. No? Just divide equation 1 and 2. So when you divide 1 and 2, what we get is we get R by S divided by it's R into 12 plus S divided by 12S, which is equal to this is 2 by 3 by 2. See, this S will cancel this S. This 12 will go to numerator and you will get it's 12R divided by R into 12 plus S is equal to 2 by 3. This R will cancel this R. 12 by 12 plus S, it's 2 by 3. When you cross multiply them, you get 36 is 24 plus 2s. So it's 12 is equal to plus. So S is 6.
6.
Good to know. Then once you have S, you can substitute this value of S in any equation. Let's call this as equation number 3. What I do is I just substitute its value in equation number 1. Ishma, is it clear? Minashi?
Yes, sir.
Ishma, what happened to them? You're not answering questions. You're not getting this topic.
So it's a little confused.
You're still confused? Okay, let's revise it. So R is 2 by 3 into 6. So that's 3. 4. So R is 4 and S is 6. At least note down these calculations, then I will revise it. Minashi, you do have doubts in this topic. Maharaj,
Yes, sir.
where were you for the last half an hour?
I was late, sir. Just left. Overslept.
Does everyone have written? See, Hishma, I'm repeating it again. See, for meter bridge, if you have meter bridge, then we have two resistors, one in the left gap and then there is the right gap. This we have done. The resistance in the left gap is R1, the resistance in the right gap is R2. And the balancing length is L. The relation between R1, R2 and L is this. R1 by R2 is L by 100 minus L. Is it clear up to here, up to this calculation?
Yes, sir.
Let's come to this numerical directly. The numerical says in the meter bridge, The null point is found at 40 centimeter. This R and S is given in question. This figure is a part of the question. So in the left gap, you have resistance R. In the right gap, you have resistance S. And the balancing length is 40 centimeters. The formula says R1 by R2 is L by 100 minus L. Instead of R1, I'm using R. Instead of R2, I'm using S. So R by S is 40 by 100 minus 40. That's 40 by 60, which is 2 by 3. R by S is 2 by 3. Ishma, clear up to here?
Yeah.
Then he's saying that now you put a resistance of 12 ohm in parallel with this, the second condition. So when you put a resistance of 12 ohm in parallel with this, the resistance of S will change, right? It will be now the parallel combination of 12 and S. And this is how we calculate parallel combination. So what is the resistance in the left arm, Hishma?
So in the second condition?
Yeah, in the second figure. Left arm. Left, 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 left. That's left and that's right.
At left is that
It's R. Huh? On the right,
12s by 12 plus.
so it's R by 12S by 12 plus 6. And see, the balancing length changes. Balancing length is 50 centimeters. So instead of L, I place 50 and 100. Is it clear?
Yes, sir.
Now that I make two equations and solve. Okay,
Okay.
let's see if I have it. Okay, this is another question on. Okay, note down this question. Note down this question. Nabil Khan, you still have doubts in this topic?
Sir, could you say how on interchanging R1 and R2, the balancing conditions don't change?
Balancing condition don't change on changing galvanometer itself, not RNS. On changing R1 and R2, balancing condition was changing. See, just 1 minute. When we change balancing condition, then see, when we change R1 and R2, balancing condition is changing. Instead of L by 100 minus L, we are using 100 minus L by. Okay, Nabil?
Yes, sir.
But on interchanging galvanometer and cell, the balancing condition will not change. And how it will not change, it's you can explain. See, this is a Wheatstone will, right? This is the galvanometer. This is R1. This is R2. I'm just coming to the numerical, but let me first answer this. This is R3 and this is R. And this is the same. So I'm saying that if I interchange this cell and galvanometer, balancing condition will not change. Let's see. Instead of the galvanometer, I place the cell. And instead of the cell, I place this galvanometer. This resistance is R1. This resistance is R2. This is the R3. And this is the R4. Now what I can do is, these are wires now. I can stretch these wires. I stretch this wire and take this cell outside, and I compress this wire and bring this galvanometer inside. This is galvanometer. This is R. This is R. This is R. This is R. And this is your cell. Now this and this circuit is just rotated by some 90 degrees. The balancing condition is R3 by R, is R4 by R. If you cross multiply them, then you can write this as R2 by R, R2 by R is R4 by R. The same condition, na? R1 by R2 is R3 by R4. Okay, Nabil?
Yes, sir.
So interchanging cell and galvanometer, balancing condition. Please write this question, we'll solve it. Yes, everyone have written this question.
No, sir.
No, sir.
Tell me once you have written the question, start the calculation. Yes, written. Nabil, Akshay,
Yes, sir.
Yes, sir.
Yashika.
Yes, sir.
Okay, let's solve this question. So when two known resistance R and S are connected in left and right gap of the meter bridge, means initially we just have resistance R and X in the left and right gap. Hishma, what is the balancing length now? If you just have resistance R and S?
L1.
L1. How will you relate R and S and L1?
R by S is equal to L1 by 100 minus L1.
Okay. So this is how we relate them. R by S is L by 100 minus L. So R by S is L1 by 100 minus L. On the left gap, you have resistance R. In the right gap, you have resistance N. Balancing length is L. So L1 by 100 minus L. That's my first. Next, what we did is saying that meter with unknown resistance X is now connected in parallel to resistance S. So now the bridge will look like in this way. This is R. This is S. In parallel with this, you have another resistance X. This is X and this is X and this is R. Arpit, what is the resistance in the right gap?
7 by X plus 1 by S.
And how much is it? Remember this thing. If you have two resistance in parallel, X into S by X plus S. Nabil Khan, can you relate this R, X's and the balancing length? What is the balancing length now? It's the same L1 or it's changed?
Change.
How much is balancing length now? It's L2. Nabil Khan, can you relate this R, the resistance in the right gap and this balancing length? Saifullah?
Sorry, can you repeat your answer?
Sir,
Can you-
L2 into x by 100 minus L2 into s plus x is equal to L1 by 100 minus L1.
see, the left gap you have R, the right gap you have it's x into s by x plus s. Balancing length is L2, and then you have 100 minus. That's the second one. Now you have to calculate the value of x in terms of L1, L2, and S. Means you somehow have to eliminate this R. To eliminate this R, what we can do is we can just divide them. So when we divide them, we get x in terms of L1, L2. Just note it down and do the rest of the calculation. Just divide 1 and 2 and you will get x in terms of L1, L2. Nabil Ahmed, what's your answer? The answer you're getting?
Sir, L2 into x by 100 minus L2 into x s plus x is equal to L1 by 100 minus L1.
What are you calculating?
I first took R by S is equal to L1 by 100
And that's
minus,
fine. That's fine. Your equations are
and
correct.
then
I'm asking you in the final answer, you're supposed to calculate x in terms of L1, L2. So solve this equation in a way that on one side you have x and on the other side you have L1.
yes, sir.
Then only you will get the expression. And others also, just do this calculation and write your answer in chat room. Especially Nabil Khan, Hishma, Minashi, and Mehraj. I want your answer in chat room. See, just divide these equations and get the value of x.
Sir, in denominator I'm getting x s plus x, sir.
Just remove it somehow.
X s plus x, sir. Like how can I remove?
You can cross multiply them, take x as common. See, the calculation would be lengthy. If you want, you can just dictate me your answer. If you can't type it in the chat room, you can just dictate me your answer on X. Till now, I just got one answer from Nabil Ahmed. That's it.
We have to find the value of
X.
S.
See, read the question. X.
Yes. Okay.
In terms of L. Yashika, your answer.
Sir, it's very long.
I just dictate it. No? How much is it?
Sir, L1 by 100 minus L1 into 100 minus L2
It's numerator.
upon L2
And
into x plus x by x. X,
X plus S by X.
yes, sir.
Now just tell me, can it be the right answer? Yashika, you are calculating X in terms of X. Is the solution of the equation? This is fine, Nabil, but still you need X now. You need X on one side and all other variables on the other side. Yes, Yashika, tell me, is it the right? Is it the right answer?
No, sir.
You're writing an unknown in terms of unknown. It's not the solution of it. Anyone else? Minashi, are you in class?
Yes, sir.
You're calculating?
Yes, sir. I'm stuck.
Okay, it's done. Just tell me what value of X you are getting. Your calculations are completed, no?
No.
Oh, still doing good. Just divide 1 and 2. Divide these two equations. I don't know why you people are doing mistakes in calculation. Simple calculation. Divide them. Take common. Write X. Akshay. Akshay, it's very simplified. I doubt that. There's negative sign here, Akshay.
Minute S x plus s to the right side, so x equal to minus s by that.
I have doubt in this answer. I don't think it's correct. Yeah. Check your calculation. Up with you are calculating again, yeah. You are also calculating x in terms of x. When you solve an equation, you solve a variable in terms of other variables. Right? See your x you are calculating and your answer you are getting x plus s.
So
Maharaj.
into L2 into 100 minus L2.
Just
By,
1 minute. Can repeat again. Repeat it again.
So S into L1 into 100 minus L2 divided by L2 into 100 minus L1 is equal to X.
Seems good. Saifullah, what happened?
Sir, how will it get cancelled, sir?
Will not get cancelled. Okay, I'm doing it. Saifullah,
Sir, 1 minute. 1 minute.
okay, I'm giving one more. Nabil Ahmed got the right answer. Yashika, तुम्हारी भी calculations बिगड़ रही है ना? One minute is over, Saifullah. Do you get any answer? No. Okay, let's do it together. We divide 1 into 2 now. So when we divide 1 into 2, this is r by s divided by r by. Let's first simplify this equation out here. Otherwise, this will go to numerator. So this will be r into x plus s divided by xs is equal to L2 by 100. Just check each and every step of the calculus. Simple calculation, just divide 1 into 2. So when you divide 1 into 2, what do you get? You get r by s divided by its r x plus s divided by xs is equal to its L1 by 100 minus L1. Divided by L2 by 100 minus L. S will cancel S, R will cancel R. You can take it to the numerator. It's x by x plus s is 100 minus L2 by 100 minus L1 into it. You need x. So to calculate this x, the easiest method is just take reciprocal. Take reciprocal. So when you take reciprocal, you get x plus s divided by x is 100 minus L1 into it divided by it's 100 minus L2. Now you can write this as this is x by x plus s by x, which is 100 minus L1 into it over 100 minus L2. Any doubt in calculation up to this step? Arpit? Inashi?
Yes, sir, clear.
So this is 1 plus s by x is 100 minus L1. Whereas just switch on your video. Mehraj Rahman. You can take it to the left hand side. You can take this one to the right hand side. So this is s by x. It's 100 minus L1 See, the calculations are lengthy, but yeah, tough. 100 minus L2 multiplied by 1 minus. You can take LCM though. It's 100 minus L1 into L2 minus its 100 minus L2 into L divided by 100 minus L2 into L. So if I multiply this here in the numerator, I will get it's 100 L2 minus L1 L2 minus 100 L1 plus L1 divided by its 100 minus L2. So L1 and L2 will get cancelled out. And you have 100 L2 minus L1 over. It's 100 minus L2. Now, if you cross multiply them, you get the value of it. Cross multiply them, you will get x is equal to xs. It's 100 minus L2 into L1 divided by its 100 L2. Who was getting this answer? No one was getting. Is it clear now? Nabil,
Yeah.
Akshay. Good. See, it's a very common question from your board exams. From meter bridge, you get these type of questions where the numerical values are not given, the variables are given. These are known as alphanumerical questions. Alphanumerical. And if you go to previous year's questions of JEE Mains and AIEEE, you will find these questions here. This question was initially in AIEEE exam, then it comes in boards exam. It's previous years of both AIEEE and CBSE. Tell me once you have written and scrolled it. Kinza, clear? All steps?
So here in reciprocal, why did you take reciprocal?
Because the easiest method to solve. See, if I multiply in this step only, then the calculation will come there. You can identify this step only. Like if I multiply it here, then you're multiplying whole thing with x, then you're multiplying whole thing with s. The calculation will be simple. That's why reciprocal. On the taking reciprocal, you can see this x and x will cancel. So to
Yes.
reduce the calculation. You can even solve it without reciprocal. You can take just cross multiply them. Take all terms containing x to one side.
Yes, sir. Thank you.
Arpit, clear?
Yes, sir, it's clear.
Ishma, any doubt in these calculations?
No, sir.
Abifan, you have to put more efforts in your calculation. See, you have not responded of any single question. Either you calculate the first question or the second.
Yes, sir.
See, I can only help you in calculations. You have to do your calculation. You can't learn doing calculations just by listening a lecture or just by looking at it. You learn calculation when you do it yourself. You make small mistakes. Then the thing that I'm doing will help in rectifying those mistakes. But first of all, you have to work it out. Don't worry, even if your answer is wrong. You may keep on doing wrong calculations for 1 week, and after 1 week, your calculations will become correct. In physics, you just have two things. Now, one is concept, another is calculation. I can teach concept. It's really very tough to teach how to calculate. Written? Can I scroll it up?
Yes, sir.
Okay, so this completes your meter bridge, and potentiometer is not a part of syllabus now, so I'm not discussing potentiometer. Then there is one more topic, which is heating effect of current. Although heating effect of current is not directly discussed in NCERT, in 1-2 lines NCERT have discussed that heating effect of current. So let's do it. See, let's see what is heat dissipation. I'm using my some old slides. It will save some time. At least the time that I take in writing that. So see, what is heating effect of current? See, it's a very common observation. When current passes through any device, you can take device to be your laptop also. If you connect your laptop to the charger, then then this body of the laptop gets heated up. You can take example of your fan. When current passes through your fan, then it gets heated up. So from where that heat energy is coming? Yes, can you tell me from where that heat energy is coming? It's basically the electrical energy. When you connect your laptop or any device with an electrical circuit or electrical supply, the electrical energy gets dissipated as heat. So that the dissipation of electrical energies as heat is known as heating effect of current. So if I take this resistor, we have already discussed several times that resistor means your load. In your real life, if you connect a mobile phone with a cell, then that mobile phone is resistor in circuit. If you connect a refrigerator with a power supply, then in circuit analysis, that refrigerator is a resistor. So if you have a resistor, you connect it to a cell of EMF E, then the current passes through the resistor. Due to resistance of the resistor, a part of heat energy, electrical energy gets dissipated as heat. So that is the reason of that is heat dissipated across the resistor. And what is the cause of that heat? The cause is, see, if I take a conductor, then conductor have ions and conductors have free electrons. When you connect this conductor to a cell, then cell applies some force over the electron. Due to that force, these electrons move. When these electrons move, they collide with the ions. When electrons collide with the ions, due to the collision, the electrical energy which this cell is providing to this electron gets lost in the form of heat. So due to this continuous collision of electrons with the ions, a part of electrical energy gets converted into heat energy. So the cause of heat energy is collision of electrons and ions. Now, the expression of this heat energy, we have already discussed this expression while we were doing circuits. So before doing heat energy, let's discuss power dissipated. What is power? Power dissipated. See, power is nothing but its heat energy divided by power dissipated is just heat energy divided by that. That's power. Energy per unit time is power. So we represent power with P. So there are various expressions to calculate power. One is I square R. You can calculate power using I square R. Or you can calculate power using this expression V square by R. Or you can calculate power using this expression as V. This is power. Now, if you have power dissipated, then you can also calculate heat energy. See, heat energy if I go through this calculation, then just multiply this power with time, you get heat energy. Heat energy is power multiplied by time. And how much is that power? That power is I square RT. Or you can say it's V square by RT. Or you can say that's V into I. So that is the relation between heat energy and power. That heat energy is simply power. We can multiply power in time only if your power is constant. If your power is variable, if electrical power is variable, then we don't multiply, then we just integrate. Then we write heat as integral of T. We just integrate. So this is relation between power and heat. Just note it down and do some numerical science. Can I scroll it if you have written?
Unanswered.
Nabil Khan, is it clear? This power, heat?
Yes, sir.
Saifullah, any doubt?
No, sir.
Answer.
Is there anyone from Bahrain, Ibn al-Hatham school? In this batch, Minashi, you're from Bahrain.
Yes.
Wherein the country topper of science is Noor Alok or is someone else? Do you have any idea? Noor was in batch last year, so he got around some 96%. Although he's the school topper, but we are confused whether he's the country topper or not. Tell me once you have written. Huh?
Sir, is it just multiplication or is it cross multiplication, sir? In VIT.
It's just multiplication.
Okay, sir.
See, heat energy is just power into time. So we have expression of power equal to that. But we multiply only if the terms are constant. If you have variable terms, then we take it. And then just write this unit of power. It's joules per second of work. It's energy by time, so it's joules per second of work. Yes, written.
Yes.
Okay, this finished current electricity. We will do just one or two more numericals on heating effect of current in the next class. And we'll be starting with chapter number 4, magnets, magnetic effect of current. So now let's start our revision of, we were doing capacitors, no? The last class we have discussed, okay, we have discussed this circuit also. No? Fine. We have discussed all types of circuits on capacitors. So now we will start the revision of current electricity. See, in current electricity, there are very few topics from theory which are a part of JE but not given in NCERT. In chapter number 1 and 2, there were several topics which were in JE main syllabus but not in NCERT. But in chapter number 3, current electricity, there are very few topics, three topics which are in JE syllabus but not in NCERT. So the first one is the concept of electric current, the first topic. So let's just recall our relations and then we'll start the numericals. So initially we don't have any relation which was not in NCERT but in JE syllabus. So I'm just repeating all terms, like the concept of electric current, I is dq over dt. This was instantaneous current. If you calculate average current, then it comes out to be delta q over. This we did. This is the instantaneous current. And this delta q by delta t is the
Average.
Then you can get questions on graph. Like if I give you the charge versus time graph and I call that this graph is a straight line, what is the slope of this graph? Now just please unmute your mics. I need answers because this is just the revision. How to calculate slope? Slope is y coordinate
And
divided by x coordinate. And what is y by x coordinate? That's current. All of you please unmute your mics. I need responses. Its slope is current charge by time, which is current. Instead of this charge versus time graph, if I give you current versus time graph, I say that this graph is a straight line.
charge.
Then what does this area will represent? This area will give charge. Area above the time axis. This area, if there is this area above the time axis, we consider this area as positive. And the area which is below the time axis, this one, this area, we consider this area as negative. The area below the time axis is negative, and the area just above the time axis is positive. So area will give you charge. Let's do a question on this simple principle. Let's say you have some current versus time graph. This is again from the previous version. This is current versus time graph. This is your current versus time. This is I. This is plus 10. This time instant is 5 seconds. This time instant is 10 seconds. And this current is 5. That's your current versus time graph. You're supposed to calculate charge. And not just charge, but also average current. You need charge as well as average current. So, Saifullah, how to calculate charge using this graph? First.
Sir, area.
Just take the area under the graph.
Area under the graph. So this area under the graph will give you charge. This area will give charge. Ishma, how to calculate this area? How do you calculate this particular area? It's a triangle. So what's the area of triangle? Ishma is not there. Hinza, how to calculate this particular area? It's a triangle.
Half BH.
And how much is B, Hinza? This is base 5, no?
Yes,
And how
sir.
much is H? 10.
10.
And this will become.
Sir, why we don't the shape under the first triangle, sir?
Sir, you are lagging. Sir, you are not audible.
Am I audible now?
Sir, you're stuck, sir.
Am I audible now? Yes, Nabil, you were saying something. Sorry, I can't listen.
Why don't we calculate the area under the first triangle, sir? That trapezium shape. Why don't we calculate that area?
Which one? This one?
Yes, sir.
We take area between the graph and the time axis. This area will give you. Okay, the area between the time axis and the graph. This is including area, not this one. See, whenever you multiply two things, I into T is charge now. Then when you go in graph theory, then the quantity which is obtained by the multiplication of y and x coordinate, that quantity is obtained by area under the graph. When we say area under the graph, that means area between the graph and the x-axis. So graph and x-axis, this area. Graph and x-axis, this area, not this area. And we need bounded area. Area bounded by graph and the x-coordinate. Okay, Nabil?
Yes, sir.
And how much is this area? It's half. How much is this length? Base.
5.
And height is also. It will be positive or negative?
Negative.
So if I calculate this term, this comes out to be 25. It comes out to be minus of 12.5. And what is the total charge? Rashika?
12.5.
Sir, the sum of the two.
Sum of the two. 12.25 plus minus of 12.5. We get that this total charge is 12.5. So when you have charge and you have time, how much is total time elapsed? 10 seconds. What is the average current, Uni? How to calculate average current?
1.
Uni,
So delta. So delta Q by delta.
delta Q. Uni is not in class. It's 12.5 divided by. Is it clear?
Yes, sir.
These are the first type of questions that you can get of current electricity. Usually these questions contains this graphical. When they ask this thing. Slow it down, do it fast. This will revise your current electricity.
Sir, this question came in neat.
Yes. I will mention, Arpit, if there is something which is in JEE but not in NEET. I will mention the topics specifically.
Okay, sir.
And I will ask you to leave when I do those topics. See, basically, in NEET now, you have 45 questions, and the division of that 45 question is out of 45, this 20-25 questions are easy. Then you have tough, then you have some very, really tough questions. And the standard of those tough questions match with that of JEE. So if you want to attempt only those 25 questions which are easy, then your NCERT is enough. Can I scroll it? Nabil, Yashika, written.
Yes, sir.
Sure. Now we will do questions, numericals, which will use this topic. Second, it will use, see, there is up to temperature dependence of resistance and resistivity. There is no theoretical topic which is not in NCERT but in JEE syllabus. So we'll do numericals based on this topic. Then we'll do numericals based on this drift velocity. What was the expression of drift velocity? Just check your notes, everyone. Tell me what was the expression of drift velocity. Just go back to your notes and tell me how much is what is the expression for drift velocity. Drift velocity.
Sir, minus E tau by M.
Minus E by M into tau.
Tau by M.
Tau by.
So this negative sign tells the direction of drift velocity and electric field is opposite. Tau is the relaxation time. Then we did this expression that current is NEAVD. We have finished that all these things in last 2 weeks only. Yeah? Then we did resistance. We did one expression of resistance. Then we did Ohm's law. Where Ohm's law, your V is equal to I. Yeah. Then we did the expression for resistance. We did several expressions for resistance, which was Vy. Then we did this expression. It's ML by AN E square tau. Then we did relation between resistance and resistivity. What was the relation between resistance and resistivity, Kinza? No, Kinza was not at that time. Minashi?
Rho L by.
Well, bad. Then we did expression of resistivity. That resistivity is M by N E square tau. Then we did several small definitions like conductivity, which is 1 by rho. Conductance, which is 1 by R. Then we did current density, J, which is current divided by area. Then we did microscopic form of Ohm's law, which says J is equal to sigma. Then we did mobility. Mobility is drift velocity divided by electric field. Then we did temperature dependency. We have discussed that if you take a conductor and you increase temperature, then resistance will also increase. But instead of conductor, if you take an insulator and if you increase temperature, then resistance will not increase, it will decrease. The same is true for semiconductors. For alloy, we have discussed that if you increase temperature, that resistance will increase, but increment is small as compared to conductors. Then we did this relation that resistance RT is R naught 1 plus alpha T minus T. So the first type of questions that you can get in any exam will use all these topics simultaneously. You can use any of these topics. These are known as three questions which are based on theoretical questions. Then the next type of questions that we will do will be on circuit analysis. You all have these expressions in your notes. If you want, you can take screenshot. I will come to questions very. Written, you take it screenshot. No? Let's solve them later. So I'm directly attempt this question first. This question number 4. Attempt this question number 4, please. Solve question number 4, 5, 6.
So should we write the question?
Yes, always write the question. Always write.
Sir, can you show the page?
Yes. Question number 4. See, any answers from this first question?
1 minute, sir.
See, formula is a simple formula based. Answers, Yashika, Akshay. I'll wait for just 1 more minute, then I'll solve this question. No answers, na? Grand problem. See, what is the expression of mobility? See, mobility we just have written, it's BD by E, drift velocity per unit electric. So see how to think. This is mobility. See, drift velocity is given, but electric field is not given. You need electric field. So first of all, just see what quantities are given. Current is given, resistivity is given, area of cross section is given. But you don't need resistivity or anything. You need electric field to calculate mobility. So do you remember any relation between this current, electric field, resistivity, any sort of relation? Yashika, can you think of any relation which can relate current, resistivity, electric field? No. See, this is the expression. Nah? J is equal to sigma E. What is J? J is nothing but current per unit area. It's current by area. What is sigma? It's 1 by rho. What is electric field? It's E. So this is E, which is rho I by A. You put the value of electric field here. So mobility will become it's Vd by rho I and A. Is it clear?
Yes, sir.
Substitute the values. You have Vd, which is 1.1 into 10 raised power minus 3. Then you need A. Area of cross section is 5 mm. Radius of cross section is 5 mm. So area will be pi r square. Rho is given 1.7 into 10 raised power minus 8. Current is given to 5. Rashika, clear? Note it down. I'm not calculating the numerical value it will take. It will consume too much of time. You can calculate the numerical value now, no? Written. Can we move on to the next question?
1 minute, sir.
Tell me once you have written. I'll start the second question. So can we start the next question? Question number 5.
Yes, sir.
See, question number 5. This is again based on NCERT. Just tell me what formula you will use. You have completed the entire current electricity. Just turn your notes and tell me which formula you will use to calculate the resistance. This is in your notes. You have done this type of question in class. Not exactly these type of question, but you have done this question. Just tell me what formula you will use to calculate resistance if you have resistivity and geometry. Just I'm asking only the formula, nothing else.
R equals rho L by A.
Very good. The formula that we'll be using is R is rho L by A. Now, see this type of question. Radius A and B. So this is your first sphere. The radius is A. Then you have
Yes.
second sphere. The radius is B. When you write this relation, and you need resistance between the inner and outer sphere. So you need relation between this inner sphere and this outer sphere. So what is L here? What does L means in this relation?
Length.
Length means the separation between the 2 points at
A and
which
B.
you are calculating the resistance. So basically this is the L. And what is A? A is the area of the surfaces at 2 ends. The area of this surface is 4 pi A square. And area of this surface is 4 pi B square. So when you go from one end to another, is area same or area is changing?
Changing, sir.
Changing, sir.
Area is changing. So when area is changing, you can't use this relation directly. You will need integral. You can write it somewhere in your notes. If area is changing, if your area is variable, then you can't calculate directly from it. You need integral. So what we will do is, we will consider a small sphere in between them. And if you can remember, we did these calculations in electrostat also. The thickness is dx. The radius of the sphere is x. The resistance is dr. We first calculate the resistance of this small sphere that we take in between two spheres of radius A and radius B. The resistance is, use this expression, rho. Instead of L, we'll be using the thickness, dx. Instead of A, we'll be using the area of the sphere, which is 4 pi x square. See, why are we using this dr in form integrals? Because area is not constant, area is variable. It's changing from the inner sphere to the outer sphere. Now let's calculate resistance. What is resistance? It's rho dx. It's 4 pi x square. It's A to B. So the resistance, it's rho by 4 pi. You can integrate it. 1 by x square is minus 1 by x. Integral is minus 1 by x. Limit is 1 by A to B. You can take this minus sign outside and you can write this as minus rho by 4 pi. 1 by B. Or you can take this negative sign inside and you can write this as, this is rho by 4 pi. 1 by A. To match the options, you can take LCM and both sides. But remember, we can use this expression directly rho L by A if L and A are constant. If A is constant when you go from one end to another. But when you go from one end to another and A is not constant, it's variable, then we can't calculate it directly. We calculate it using integral. We take a small element, we take resistance of that small element, and then we integrate it from the initial. Yes.
Can we find the area of the space between those two? Like,
yes, we can calculate the area of that space also. That will be pi b square minus pi a square. But that's not the point, because when you go from one sphere to another sphere, the area is constant or it's changing on it.
changing.
It's changing. So when area is changing, you can't take L. Because when you write this expression, this means across this area is here, this length is L. Then you write this expression rho L by. This area means the area should be constant when you take length. But if your area is changing, like you can't use this expression directly. You have to take a small element, you have to take resistance of that small element, then you will integrate it from initially defined. Yes, clear?
Yes, sir.
Okay, we'll stop here in the next class. But please see, I can help you in solving this NEET JEE questions only if your NCERT is clear. If you forget your NCERT thing, that's not at all possible to do this JEE. So in the next class on Monday, we will be discussing questions on this temperature dependence, this relations on temperature, these R is rho L by. So please at least revise it from the class notes. Then we can move on to the next level. Okay, so we'll stop here and continue this in the next class.
Thank you, sir.
Thank you.